Now we have good afternoon. We have actually this lecture number that is 6. In this we are going to be with Eigen values and Eigen vectors. And Eigen vectors. Now here we have a minus lambda I and that is equal to 0. And by using this, we are going to calculate these values of lambda, which are our Eigen values. So now we will go with this. The smallest eigenvalue and the corresponding eigenvectors of the following matrix are. This was asked in 2021 set 1. So we have seen A minus lambda I. So this is A. Now minus, you can see this. I means we have 1, 0, 0, 1. And if I will multiply it by lambda, then we are going to get this as lambda. This will be lambda. And then we have a minus lambda I means now this becomes minus minus. And therefore it becomes 2 minus lambda minus 2 minus 0, minus 1 minus 0, and 6 minus lambda. So in A, we have to add this. So automatically your first and fourth, this will becomes with minus sign. So you can see this 2 minus lambda, minus 2 minus 1, 6 minus lambda. And then we are going to calculate their determinant and that we are going to equate it to 0. So we can have this lambda square minus 8 lambda plus 10 and that we have equal to 0. So this is equal to 0. So we are going to get lambda square minus 8 lambda plus 10 and that is equal to 0. Now we will calculate value of lambda which will be by using formula. So we have this will be minus b plus minus root of b square minus 4ac upon 2a. Now value of a we have 1 over here. Value of b we have minus 8 and value of c we have 10. And we have substituted value minus of minus 8 plus 8 plus minus b square that is minus 8 square 64 minus 4ac a1 c10 and likewise we will get 4 plus minus root 6. And from this we will get this as 2 minus 4 plus root 6. So we have smallest value. So we will get one value that is 4 plus minus root 6 and lowest if I will say then we have 4 minus root 6. So we will have this will be minus minus 6. So 4 minus root 6 and minus sign we have minus lambda. So it becomes minus 4 plus root 6. Then minus 2 and here also minus 4 minus root 6. Yes, no, sorry, here that is correct. We have both we have actually correct these values. So we have this as minus 4 plus root 6. And now we will have this equal to minus 2 plus root 6 minus 1 2 plus root 6. Now try to understand again. I will explain it. So we have two values of lambda. One is 4 plus root 6. We have another value. This will be lambda 1. Another value we have 4 minus root 6. Now if I will put it here, then we have 2 minus in bracket 4 minus root 6. Then it becomes 2 minus 4 plus root 6. So 2 minus 4 plus root 6. Similarly for 6 minus lambda, 6 minus 4 minus root 6. So 6 minus 4 plus root 6. 6 minus 4 plus root 6. So we have likewise. So we have minus 2 plus root 6 minus 2 minus 1 2 plus root 6. Then we are with minus 2. So here we have x1 y1 x1 x2 and that is equal to 0 0. Then we have minus 2 plus root 6 into x1 minus 2x2, that is equal to 0. And from this we will get minus 2 plus root 6 into x1 equal to 2x2. Now whatever coefficient of x2, that is value of x1. So we are x1 equal to 2 and we have x2 that is equal to minus 2 plus root 6. And this value comes something minus 2 plus 2 0.46 likewise, because 24 square we have 576 and therefore 246 it will go to the 6 and then we will get it as 0.45. So we have these values, that is x1 and x2, that is 2 and 0.45. So likewise, we are going to get these values, that is x1, x2 means we are going to get these values, that is of given eigenvectors. So from this 2.4, so this is one of the eigenvector. Then you can calculate another by using this, where we have to use 4 minus 4 plus root 6. If we are going to be largest, then we are going to be use this. Then Eigen value, this was asked in 2020. So we have likewise. Then we have to subtract from diagonal, that is A minus A lambda. Now how we will have this matrix? So we have I matrix lambda 0, 0, 0, 0 minus lambda 0, 0, 0, 0 minus lambda 0, 0, 0, 0 minus lambda. And therefore we have this as first we have 0, and then if you will calculate that one, then we have 3 minus lambda, then 6 minus lambda, then 6 minus lambda. Now it is difficult to go for this 4 by 4 matrix by using this and calculate the value. Now in this, we have two criteria for these Eigen values. So we have criteria for Eigen values, that trace equal to sum of all Eigen values. Sum of all Eigen values. Trace means we have sum of diagonal members. Sum of diagonals, and that is equal to sum of all Eigen values. Now what are sum of diagonals? What is value of trace? So we have this as trace 0 plus 3 plus 6 plus 6, that is addition of the diagonals. So we have this is one part 15, and another we have, that is determinant equal to determinant, that is equal to product of all Eigen values. Product of all Eigen values. So these two are most important. Trace is the sum of all Eigen values and determinant is product of all Eigen values. So now we have first, that is this is, we can write it as trace. Now we will go for determinant. So you can see we have now these are zeros. Now I have made it 0. So how we have made this 0? So we are going to be 0, 1, 3. So we have multiplied this. I can write this as C3, that is equal to C3 minus 3C2. And then minus 3 into 1. Minus 3, 0, minus 3 into 3, minus 9. So we have this as minus 9. And so why I have made this? So that I have these 3 are 0. So only I have to calculate 1. So we have likewise, this will go and this will go. So what will remain in that case? We have minus 2, 0, 0. Then we have minus 9, 6, 1. And then we have 4, 1, 6. And this one is our minus 1 is outside because we have second column. So minus, now again minus 2 for this, and then 36 minus 1, this value. Now for this minus 9, you can see if we will go likewise, this goes and this goes, 0 into 6 0, minus 0 into 1 0. If we will go for this will be 0 into this 0 and 0 into this 0. So we have only this value, which will be 17. And now you can have, we have these four options. Now we have trace 15 and determinant 70. So if I will go for this 6, 12, 15, but 6, 6 are 36, 3, 1, 0, 8, not matching. 4, 3, 2, 1, 4, 3, 7, 2, 9, 1, 10, no. 7, 5, 12, no. 7 plus 5, 12 plus 2, 1, 14 plus 1, 15. 7, 5 are 35 into 2, 70. So our option is this. So we have Eigen values 1, 2, 5, 7, and this matches both of this. Then we have the matrix we have given likewise, and then we have to find Eigen values. So we have now this as 4 minus lambda square, and we have this. We have to actually, four options are given, the matrix has, and we have which option is correct. Question is which option is correct option? Which option is correct option? Which option is correct? So now we have this will be, then we have calculated this will be my Eigen matrix 2 minus lambda minus 4, 4 to minus 2 minus lambda. And from this we will get minus 4 plus lambda square plus 16. Now this minus 2 lambda plus 2 lambda minus 2 lambda gets cancelled, and we have lambda square plus 12. And from this we will get lambda equal to plus minus in bracket root minus 12, because this is calculated by using lambda square, we have plus 12 equal to 0, and therefore we have lambda square equal to minus 12, and from this we will get lambda is equal to plus minus root of minus 12, which will be equal to plus minus root of 12i. And now this is complex because I is there. So if my lambda is complex, that is Eigen value complex. Eigen value complex. So automatically my Eigen vector also complex. Eigen vector also complex. And therefore we have Eigen value and Eigen vectors, both are complex. And we have this option. Option number 4, both are complex. Then we have next consider the following simultaneous equation and write characteristics equation. So now how we will go for characteristic equation means again we have a minus lambda I. This is characteristic equation only. And therefore we have this as 3 matrix. If we will see, then you have 3, 2, 4, 1. And then we are going to be with 3 minus lambda 2, 4, 1 minus lambda. And from this we will get characteristic equation lambda square minus 4 lambda minus 5 minus 4 lambda minus 5 equal to 0. So this is characteristic equation for these simultaneous equations. Then consider the following statement, which matrix which statement is true. Now we have 5 minus 1, 4, 1, and then we are going to be characteristic equation 5 minus lambda minus 1, 4, 1 minus lambda, and we have calculated it as lambda square minus 6 lambda plus 9. So it is my lambda square minus 6 lambda plus 9 equal to 0. And you can see we have this as lambda minus 3 whole square. That is equal to 0. And from this we will get lambda minus 3 equal to 0 and lambda minus 3 equal to 0. And therefore we have lambda equal to 3 from both cases. And then you can see the statement eigenvalue 3 has multiplicity of 2 and only one independent eigenvector. So we have this only the answer of the question. So this is correct answer we have. This is correct answer. Now others you can see Eigen 3 has a multiplicity of 2 and 2 independent eigenvectors. Now we have one independent eigenvector. So which eigenvectors we are going to get? That is 5 minus 3 minus 1, 4, 1 minus 3. So we are going to get eigenvector. This is eigenvector which will be 2 minus 1, 4 minus 2. So this is my eigenvector. Means this is x1 y1, so we can have this x1 y1 and we can find this eigenvector for this. So but we are going to get this by using eigenvalues. We are going to get these values. So eigenvalue 3 has a multiplicity of 2 and no independent eigenvector. Eigenvalues are 3 and minus 3 and 2. So these all are wrong. So we have first option. Then two eigenvalues of the following matrix has a ratio of 3:1 for p is equal to 2. What is another value of p? 2015 we have asked. And then we have this will be a minus lambda I, and from this we are going to get this. So we have this will be 2p minus 2 plus p lambda plus lambda square minus 1. And if we will solve this, we are lambda square minus 2 plus p lambda plus 2p minus 1, and that is equal to 0. Now we know some of the eigenvalues we have, sorry, trace equal to sum of the eigenvalues. So we have lambda 1 plus lambda 2, and we have this as 2 plus p. So lambda 1 plus lambda 2. So we have 2 plus p. We have this will be diagonals. And that value we will get as 2 plus p. Now lambda 1 into lambda 2. So we have to find determinant of this, and we have 2p minus 1. So we have 2p minus 1, that will be determinant. Now we have given lambda 1 upon lambda 2, that is 3:1. So we have lambda 1 upon lambda 2, 3:1. Now you can see we have three equations, 1, 2, 3, and unknowns we have, that is lambda 1, lambda 2, and p. So we can solve this. So first we will put value of lambda 1 from this. So we have relationship in this, that is lambda 1 is equal to 3 lambda 2. And I have substituted this value in this equation. So 3 lambda 2 plus lambda 2 equal to 2 plus p. So we have 4 lambda 2 equal to 2 plus p. This is one equation we have. Now we can substitute this value of 3 lambda 2 as a lambda 1 from this to this equation. So we have 3 lambda 2 into lambda 2, 2p minus 1. And from this we are going to get this as 3 lambda 2. So we will go one step more. So we have, or we can go from this. So we will calculate from this lambda 2, that is equal to 2 plus p upon 4. And now I will substitute this lambda 2 value in this equation, and then we can have 3 in bracket 2 plus p upon 4 over here, and that is equal to 2p minus 1. We are going to substitute in this. So this 4 plus 4, 16. I have directly taken this value on this side. And then we have solved this. So we have 12. So if we will 2 plus p square, so we have 4 plus 4p plus p square, and we have multiplied by 3. So we have 12 plus 12p plus 3p square equal to this one 32p minus 6. And from this we are going to get this one equation, that is 3p square minus 20p plus 28. And if we solve this equation, that by using p equal to minus b plus minus root of b square minus 4ac. So 84 into 4, because this is 28 into 3, 4 into this is c, this is a, and then we have this as 4. So we have 6, 326, and divided by 2. And from this we will get 20 plus minus root of this will be 64 upon, sorry, 2 into 3, 2a. Formula keep in mind, minus b plus minus root b square minus 4ac upon 2a. In this, a is 3, b is minus 20, and c is 28, and upon 6. And then from this we will get 20 plus minus 8 upon 6. And now if we will go 20 minus 8, so we have 20 plus 8, so we have 28 upon 6. This will be 14 by 3. And then 20 minus 8, we have 12. 12 by 6 will be 2. So now 2 already we know. So our answer is 14 by 3. So another value we have for P, that is 14 by 3, which will give us eigenvalue ratio as 3:1. Then the smallest and largest eigenvalues for the following matrix. So we have this. So now again we have to go a minus lambda I. So 3 minus lambda, 4 minus lambda, 5 minus lambda, and then we can have 3 minus lambda. This will be over here into minus 4 minus lambda, 5 minus lambda, and minus 3 into 6 plus 18. Then minus of minus, this will be plus 2. And then we have 4 into 5 minus lambda, 6 into 2. So we have calculated this determinant actually. And then we have plus 2 into minus 12. And this 2 in minus 2 into 4 minus lambda. And from this we are going to get equation lambda cube minus 4 lambda square plus 5 lambda and minus 2. Now if you remember, we have this one method where we have this as 1 minus 4, 5 and minus 2. This is lambda cube, lambda square, lambda and constant. Then this one will be, we will say lambda minus 1 equal to 0, because 1 minus 4 minus 3 plus 5, 2 minus 2, 0. Hence we have lambda equal to 1. So I will substitute 1. So this 1 we will take below. So 1 into 1, we have 1. So it will come minus 3. Minus 3 into this 1. Then we have minus 3. So it will come 2. 2 into 1, minus 2, then 0. Now this becomes lambda square. This will be lambda. This will be constant. So we have lambda minus 1 in bracket lambda square minus 3 lambda plus 2, that is equal to 0. Now you can have lambda minus 1, and that is in bracket lambda square minus 3 lambda plus 2. So we have lambda minus 2, lambda minus 1, that is equal to 0. From this we will get lambda is equal to 1 to 1. So we have smallest and largest eigen values. So we have 1 and 2. So likewise, actually, we have to go. You have this method that is in 10th. You can go over there and you can check it. So now we have lambda 2, 1, 1. Largest is 2, smallest is 1. Then sum of eigenvalues for the following matrices. So this was asked in 2014, and we know that is trace of the matrix, and trace means we have to just add the diagonals. So we have this value as 915. Then we have the eigenvalues of the following matrices. Now we will go a little bit fast because we are in the same fashion. So now here we are going to be lambda square minus 17 lambda plus 47 equal to 0. So A we have 1, B minus 17, and C we have 47. And therefore we have 17 plus, now we have this will be multiplied by 4. So 4 sevens are 2, 18. And we have 17 square, 289. So minus 188. So it comes 101 upon 2. And then if we will see this, this is around 101 means 100. So if I will consider it as 10, then 17 plus minus 10 by 2. So we are going to get it as 27 by 2, 13 point something 51 you will get, and then 7 by 2, which will be 3.5. So we have these two values for lambda for this matrix. Then we have eigenvalues was as 2008. So we can have this lambda square plus lambda minus 30. So we have lambda square plus lambda minus 30. And then we are going to get this. So now here we can directly go. This is plus 1. So 6 and minus 5. So lambda plus 5, 6, lambda minus 5 equal to 0. And we have eigenvalues. That is lambda equal to minus 6 and lambda equal to 5. The smallest and largest eigenvalues for the following matrix are minus 2 and 6. What is other eigenvalues? Now we know if we will add these three, then that is trace of the matrix will gives me sum of all eigenvalues. So 7. So minus 2 plus 6. We have to find out one value which should be equal to 7 because we have this trace that is equal to 7. And then from this we are going to get value of x equal to 3. So smallest minus 2, largest 6, and in between these we have this value as 3. Then we can have again two values are given in the same way, and they have asked. So actually problem that was following matrix and one value of the eigen is given. So the smallest and largest value, this problem that is actually from last one. So problem was they have given one value. They have given one value that is 3 and you have to find out other two values. One value is 3, other two values we have to find. Options are given. Then we have this will be x plus y equal to minus 2. Now these are the four options. One value is given. One value is 3 and we have to find the other two. Now we know x plus y we should have minus 2. Now we have to check is 2 minus 5 minus 3. No, 3 minus 5 minus 2. So we have this option. So 2 plus 5 not possible. This not possible. So we have one is 3, other is also 3, and then we have third will be minus 5. This was asked in 2006. The eigenvalues of the following matrix. Then we have given this matrix and we have to find values. Now simply we have this will be lambda square minus 5 lambda is equal to 0. Lambda in bracket lambda minus 5 equal to 0. And therefore we have lambda is equal to 0. Lambda is equal to 5. Then again we have one problem from this. So we have this was asked in 2002 and then we have here again lambda square plus 2 lambda minus 15 equal to 0. So we have lambda square plus 5 lambda minus 3 lambda minus 15 means we are going to get it as lambda plus 5 lambda minus 3 equal to 0 and therefore lambda minus 5 lambda equal to 3. So we have likewise problems again 2002 and then we have this equation. Now I am going very fast. So lambda square minus 14 lambda plus 39 we do not have any solution and from this we are going to get these values 7 plus minus root 10 and these four options are given. Now we know this will be 3 3s are 9. So 7 plus minus 3 point something and then we have this will be 3 point. Now you can have this option because 7 plus 3. So 0.16 if we will write 10.16 and 7 minus 3.16 4.84. Other options we are not going to match it and therefore we have these values that you have to understand how we will go to the correct values because we do not have calculator to calculate a root 10 value. So this will be close to 3 that is higher than 3 and will be 3.16. So likewise we have these problems which are which were asked in GATE examination. So we will stop here only. Thank you.